Hello everyone. Welcome to Sally and Bytes. Today, we're diving into the fascinating world of big data to see how it powers everything from your favorite apps to global innovations. So, grab your favorite snack, sit back, and let's unravel the secrets of big data together. So, what exactly is data? Data is information or numbers collected for analysis or reference, used in many fields like education, research, business, etc. Think about the information in your phone contacts, messages, photos, videos, music, etc. For example, every time you post a picture or like a video, you're creating data. Data is stored as a series of bits that have a value of either 1 or 0. 1 byte is a unit of digital information storage made up of 8 bits, commonly used to represent a single character like a letter or digit. 1 kilobyte is 1024 bytes. It's often used to measure small files, such as a short email or a small text document, which is about 1000 characters long. 1 megabyte equals 1024 kilobytes. This unit is common for medium-sized files, like a minute of MP3 music or a high-resolution photo, which typically range from 1 to 5 megabytes. 1 gigabyte is 1024 megabytes. It's usually used for larger files, such as an hour of standard definition video, which can be around 500 megabytes to 1 gigabyte. 1 terabyte equals 1024 gigabytes. Terabytes are used for extensive data storage, like storing about 250,000 MP3 songs or 500 hours of high-definition video. 1 petabyte is 1024 terabytes. It's a measure for very large data volumes, equivalent to approximately 13.3 years of continuous HD video. 1 exabyte equals 1024 petabytes. It can store data comparable to 11 million 4K movies. 1 zettabyte is 1024 exabytes. This unit measures massive data amounts, like 250 billion DVDs worth of data. 1 yottabyte is 1024 zettabytes. It's a vast amount, approximating the total data generated globally each year. In a nutshell, kilobytes often used for text documents or small images. Megabytes common for medium-sized files like songs or high-resolution photos. Gigabytes typical for videos, software, or large collections of files. Terabytes, used by large organizations for extensive data storage. Petabytes and beyond, necessary for big data, cloud computing, and large-scale digital archives. We all use smartphones, but have you wondered how much data it generates in the form of the texts you send, phone calls, emails, searches, photos, the videos you watch, the music you listen to, even the steps you take every day tracked by your fitness app? Let's have a look at the data generated per minute on the internet. Snapchat, 3.5 billion snaps per minute. Instagram, 66,000 photos and videos shared on Instagram. Facebook, 510,000 comments posted on Facebook every minute. LinkedIn, 20.8K people are active on LinkedIn each minute. X, formerly Twitter, 350,000 tweets are sent every minute. Google search, 6.3 million searches happen on Google every minute. Video streaming, 452,000 hours of content consumed on Netflix every minute. YouTube, 3.5 million YouTube videos are watched each minute. And what about the other things people are doing on their phones? Like texting, emailing, and more? That is, online and mobile communication. 16.2 million texts are sent every minute. Mobile app downloads, 174,000 apps are downloaded each minute. Online shopping, 6 million people are shopping online every minute. With the increasing number of people and cities connected to the internet, datasets are increasingly larger in size. One report estimates that the total size of digital data will be 175 zettabytes in 2025. A single zettabyte is a trillion gigabytes. To put it in perspective, if each gigabyte were a brick, 175 zettabytes would be enough to build over 4,000 Great Walls of China. There's an ocean of data. It's like imagining to count all the grains of sand on a beach. This is quite a lot for traditional computing systems to handle, as it can handle 30 to 300 gigabytes monthly. And this massive amount of data is termed as big data. Big data systems process terabytes to petabytes daily. So, what is big data? Big data is a term used to describe a huge amount of data that is so large and complex that traditional data processing tools can't handle it efficiently. The data is not only voluminous, but also unstructured, like our posts, instant messages and chats, photographs that we share through various sites, our tweets, blog articles, news items, opinion polls and their comments, audio-video chats, etc. Big data not only represents voluminous data, but it also involves various challenges like integration, storage, analysis, searching, processing, transfer, querying, and visualization of such data. Let's see the sources of big data. Where does big data come from? Healthcare, data from patient records, medical imaging, genomic sequencing, and wearable health devices. Manufacturing, data from production lines, industrial sensors, supply chain management, and operational efficiency systems. Education, data from online courses, student performance metrics, learning management systems, and educational software. Transportation, data from GPS tracking, traffic monitoring systems, public transit usage, and logistics operations. Energy and utilities, data from smart meters, power grid management, energy consumption patterns, and utility services. Retail, data from point-of-sale systems, customer transactions, inventory management, and online shopping behaviors. Finance, data from banking transactions, stock market activity, financial trading systems, and economic indicators. Media and entertainment, data from streaming services, social media interactions, online gaming, and content consumption patterns. Government, data from public records, census information, urban planning, and governmental operations. Telecommunications, data from call logs, mobile network usage, internet traffic, and service quality monitoring. So how do you classify any data as big data? This is possible with the concept of 5 V's. Volume, velocity, variety, veracity, and value. These form the characteristics of big data. Volume, this is about the amount of data. Big data involves huge volumes of data that are often too large to handle with regular tools. Example, think about how many photos are uploaded to Instagram every day. Millions of photos create a massive amount of data, so much that it needs special systems to store and analyze it. It is very common to have terabytes and petabytes of the storage system for enterprises. Velocity, this refers to the speed at which data is generated and processed. Big data comes in fast and needs to be handled quickly. Example, imagine watching live comments on a popular YouTuber's live stream. Thousands of comments appear every second, and they need to be displayed almost instantly. They often discard old messages and pay attention to recent updates. The data movement is now almost real-time and the update window has reduced to fractions of the seconds. This high-velocity data represent big data. Variety, big data comes in many different types and formats. It's not just numbers and text, but also images, videos, and more. Example, your smartphone collects various types of data, text messages, photos, videos, GPS locations, and even your fitness tracker data. Each type of data is different but can be analyzed together. Veracity, this is about the accuracy and reliability of data. With big data, you have to deal with data that might not always be clean or accurate. Example, when you search for information online, some results are true and reliable, while others might be false or misleading. Sorting through this to find the accurate data is dealing with veracity. Value, not all data is useful. Value is about extracting meaningful insights and benefits from the data. Example, social media companies analyze your likes and posts to show you ads that interest you. They find valuable information in your data to decide which ads to show you, which can be useful for their business. These 5 V's help in understanding and managing big data effectively. Let's have a look at the traditional data processing tools and their limitations with big data. Relational databases, RDBMS. Examples: MySQL, PostgreSQL, Oracle database. Strengths: strong data integrity with ACID properties. ACID is an acronym that stands for atomicity, consistency, isolation, and durability. Efficient for structured data using SQL. Limitations: struggle with scaling and massive data volumes. Not suited for unstructured or semi-structured data. Data warehouses. Examples: Amazon Redshift, Google BigQuery. Strengths: designed for complex queries and analytical processing. Good for integrating structured data from multiple sources. Limitations: inefficient for real-time data processing. Expensive and complex to scale for very large datasets. Spreadsheets. Examples: Microsoft Excel, Google Sheets. Strengths: user-friendly and versatile for small data tasks. Easy for quick analysis and visualization. Limitations: limited to handling smaller datasets, millions of rows. Performance issues with larger data volumes. ETL, extract, transform, load, tools. Examples: Informatica, Talend. Strengths: automates data integration from multiple sources. Effective for data transformation and batch processing. Limitations: not designed for real-time or continuous data processing. Complex and resource-intensive to scale for big data. Why they struggle with big data: volume, can't efficiently manage terabytes to petabytes of data. Velocity, poor at processing data generated at high speeds in real time. Variety, limited in handling diverse data types beyond structured data. Veracity, struggle to ensure data accuracy with big data. Value, lack ability to extract meaningful insights from large datasets. Modern solutions of big data tools: distributed systems, Hadoop's HDFS, that is Hadoop distributed file system for large-scale storage. NoSQL databases, MongoDB for flexible data structures. Real-time processing, Apache Kafka for real-time data streams. Big data engines, Apache Spark for fast, in-memory processing. Why is big data important? Big data is important for better decision-making, personalized customer experiences, operational efficiency, gaining competitive advantage, managing risks, and driving innovation. Let's see how big data work. Set a big data strategy, a plan to acquire, store, manage, share, and use data effectively. For example, treating data as a valuable asset, like planning how to use a library effectively. Identify big data sources, sources like Internet of Things IoT devices, social media interactions, and publicly available data. For example, data from smart devices, social media posts, and government databases. Access, manage, and store big data, ensuring fast access, integrating data, and maintaining quality and security. For example, storing data in cloud solutions or data lakes for easy access and analysis. Analyze the data, using technologies to find insights and patterns in large datasets. For example, using AI to analyze social media trends for marketing strategies. Make intelligent, data-driven decisions, using data to guide decisions rather than intuition. Example, businesses using customer data to improve products based on feedback. These points help show how businesses and organizations can use big data to improve operations and make informed decisions. How do we store and process this big data? To do this, we take one such framework, Hadoop, as example and see how Hadoop stores process the big data. Think of Hadoop as a giant library. Instead of books, it stores pieces of data. Hadoop has two main parts: HDFS, Hadoop Distributed File System, and MapReduce. Storing data with HDFS. HDFS splits big data into smaller pieces, like chapters in different books, and stores them across many computers. Not only that, when you break the file, you also make copies of it, which goes into different nodes. This way you store your big data in a distributed way and make sure even if one machine fails, your data is safe on the other. MapReduce technique is used to process big data. A lengthy task A is broken down into smaller tasks A1, A2, and A3. Now instead of one machine, 3 machines take up each task and complete in a parallel fashion and then combining the results at the end. The processing becomes easy and fast. This is known as parallel processing. Think of MapReduce as a team of friends solving a puzzle. Each friend works on a small section, and when they're done, they put it all together. After collecting, storing, and processing the data, the next step is to analyze it to draw meaningful conclusions. Think of analyzing data as reading the finished puzzle to understand the picture it forms. Let's see some real-world applications of Hadoop in real-time analysis. Social media sentiment analysis. Companies use Hadoop to analyze data from social media platforms to understand public sentiment about their products or services in real time. Example: How Twitter uses Hadoop by Hortonworks. Fraud detection. Financial institutions use Hadoop to analyze transactions in real time to detect fraudulent activities. Example: Using Hadoop for fraud detection by IBM. Recommendation systems. Online retailers like Amazon and Netflix use Hadoop to analyze user behavior and preferences to provide real-time product and content recommendations. Example: Netflix, Big Data, Hadoop, and the Cloud by AWS. Healthcare monitoring. Healthcare providers use Hadoop to process and analyze real-time data from medical devices and sensors to monitor patient health and detect anomalies. Example: Big Data Analytics in Healthcare, Hadoop Case Studies by BMC. The power and impact of big data. Making predictions, weather forecasting using data from satellites and sensors. Example: How data helps predict storms and natural disasters. Personalization, tailored advertisements and content suggestions. Example: Why you see ads for products you recently searched for online. Improving lives, traffic management in smart cities using data to reduce congestion. Example: How GPS apps suggest the fastest routes. Privacy and ethical considerations. Data privacy, importance of protecting personal information. Example: Why you should be careful about sharing personal details online. Ethical use, how companies should use data responsibly. Example: The debate over data collection by social media platforms. Big data career paths. Big data is a lucrative field with new possibilities for experts in all industries and across the globe. With the demand for skilled big data professionals continuing to rise, now is the best time to enter the job market as big data engineer, data architect, database manager, business intelligence analyst, data scientist, database developer, data analyst. Estimated salaries in the big data field, depending on the career, range from $74,708 to $139,170 per year. How can I start my big data career? Understand the basics, learn the fundamentals of data science and big data. Familiarize yourself with key terms like data mining, machine learning, and data visualization. Educational background. Pursue a degree in a relevant field such as computer science, statistics, mathematics, or engineering. Consider online courses and certifications in big data and data science. Platforms like Coursera, edX, and Udacity offer valuable courses. Develop technical skills. Programming languages, learn Python, R, and SQL. These are essential for data manipulation and analysis. You can learn Python and SQL for free in my Bits and Bytes YouTube channel. Kindly check the link in the description box given below. Big data tools. Gain proficiency in tools and technologies like Hadoop, Spark, Hive, and Kafka. Data visualization tools. Learn to use Tableau, Power BI, or D3.js to visualize data insights. Hands-on experience. Work on real-world projects. Kaggle is a great platform to find datasets and participate in competitions. Internships. Look for internships or entry-level positions in companies that use big data. Build a strong portfolio. Showcase your projects on GitHub or a personal website. Stay updated. Follow industry blogs, attend webinars, and join professional networks to keep up with the latest trends and advancements in big data. Networking. Attend conferences and workshops to meet professionals in the field and learn from their experiences. Apply for jobs. Look for roles such as data analyst, data engineer, data scientist, or big data developer. Tailor your resume to highlight your skills, projects, and relevant experience. Prepare for technical interviews by practicing coding problems and studying big data concepts. Today, we've explored how big data goes beyond mere numbers. It's a transformative force that is influencing both our present and future. Remember, the next time you use your phone, you're part of the big data revolution. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. Stay tuned for more exciting topics on Bits and Bytes.